Hello and welcome to a video on finding an unknown angle, specifically looking at a right triangle. So let's attempt to draw one here, probably not very well, but there we go. So have a right triangle here. Can I get it to line up? Yes, I can. Okay, so we want to find this angle here, theta, and we're going to say that the hypotenuse is 13 and this side length here, which happens to be the opposite, is 7. So let's just write this out. So hypotenuse is 13 and the opposite, it has a length of 7, and we want to find theta. So we're going to use the trigonometric ratio of sine theta is equal to opposite over hypotenuse. In this case, it's 7 over 13. Just quickly, before we carry on this, I'm just going to show you one thing. If we have, let's say 1 over a, doesn't matter, I'm just using a as an example. Well, that is the same as 1 over a to the power 1. If you see something here, you know, it's to the power 1. If 1 isn't specified, we just leave the 1 off and it's a. That is also the same as if we bring it up into the numerator section, that would be a to the minus 1. So bear that in mind, because what we're going to do is we are going to have the sine here, we need to put over to this side. In fact, let's write that out again, because otherwise it's going to get a little bit messy. So we have sine theta is equal to 7 over 13. So essentially what we need to do is to divide both sides by this sine so that I can get theta by itself. So what it would look like is theta is equal to sine inverse. So this to the power of minus 1. And then that would be 7 over 13, like that. So if you throw that into a calculator, again, just make sure it's in degrees. I'm working with degrees in this particular example. That would give you 32.578 and so on. Just call it 33 degrees to two significant figures. So let's try another one. Let's say we have, pretty straight line, happy with that. Watch me mess it up now. No, it's not too bad. Okay, so another right angle triangle here. We're looking for theta there. We have 11 and we have 5. So let's write this out. So the opposite of the angle is side length 11. The adjacent is side length of 5. And again, we're looking for theta. So we're going to use the trigonometric ratio tan in this case, and if you're not familiar with the trigonometric ratios, then you haven't seen my previous videos, so I do encourage you to go back and watch some of those in the trigonometry playlist, because that will explain that a little bit more. So in this case, we've got tan theta is equal to 11 over 5. So what we do in this case is we want the tan inverse. So we use the tan inverse function on a calculator, 11 over 5. And that will give us 65.556 and so on degrees. I missed the degrees off there just to be consistent. And then let's just call that 66 degrees for two significant figures. Reason why I'm going for two significant figures here, because this 11 and then previously in this example, this 13, they're both the two significant figures. So it's good to keep it consistent there as well. Okay, so that was how to find an unknown angle in a right triangle. Please do like, comment and subscribe. Again, use that comment section if you have any questions, and I will endeavour to answer them. And thanks for watching. I shall see you on the next one. Take care.